Right now I can see the chat, so I'll be able to see if anybody's asking me questions. All right, so here is a link to the notes that I am currently looking at. Quickly, as Carlos said, I'm Brenda Huppenthal. I'll be presenting Pandas today. I am a graduate student with the Data Lab. So quickly, what is Pandas? Why would you want to use Pandas? Well, generally, okay, so Pandas is a library that was designed for Python specifically to make manipulating data, providing analysis of data easier. Python basic data structures are not as manipulable. They take much longer to process than structures in Pandas do, and this is specifically because Pandas is optimized and built on top of what's called the NumPy library. And that is a library for scientific computing. So generally, if you're working with, data that can be represented in, say, the form of a spreadsheet, you should use Pandas for this. And today we're going to be talking about generally what are the two main Pandas data structures, those being series and data frames. How you create a data structure like one of these, and more importantly, how you would read in an input file in some other format to a data frame for manipulation. We're going to be talking about indexing into the data frames, sorting them, dropping potentially null values or values that you don't care about in your analysis at this moment, etc. We'll also talk quickly about how you would merge different data frames together. So if you have like two different CSV files and you need to merge them and perform some analysis on that, we'll be discussing that as well. So here, this is the landing page. If you need to come back and you just want a quick reference on some of the basic operations in Pandas, this is where you can come. We'll be talking about most of these in the Colab notebook as well, so don't feel intimidated that we're scrolling past it fairly quickly. But yeah, this can be a quick example for you. And then down here, you'll notice these are not the ones that I will cover, but there are additional Jupyter Notebook examples. If you want to come back and you want to see some of the other things Pandas can do, or just try some new examples, you can find those here. I also really like, these are resources where you can find different data to work with in Pandas if you don't have any of your own, but you're still trying to learn. And then some other books. I wanted to point this one out specifically because I have found it very helpful. This is a data science handbook you'll have access to. I believe this one is on GitHub, but there's also a way you can get to it on the O'Reilly website. This covers not only Pandas, it covers Pandas in a significant amount of detail, but other data science tools that you may be interested to learn, including NumPy. So if you're curious about okay, Pandas is much quicker, but why is that the case? You can go back and read about NumPy, the library that it's built off, to understand why. Okay. So getting into the actual workshop now, I will put a link in the chat to the notebook that we are going to be working through today and give everybody a second to open it. And then secondly, open it in Colab where we'll be able to run the notebook. Okay, looks like everybody's ready. And please let me know if this is also too small or if it being dark mode is making it harder to read, because I can certainly change this to light mode as well. Okay, I'll assume that everybody has opened this up on their end. So for this workshop, we're just going to be working with a small Penguin data set, just to practice some of the fundamental Pandas functions. This data set is very similar to, if you're familiar with the Iris data set, this is very similar in terms of scope and those types of analyses you can run on it. But here are three penguin species here that we'll be looking at. So why are we using Pandas? Again, as I said, it's providing us dating structures and methods for manipulating data and performing some analysis on it, specifically in the form of numerical tables and time series. As per usual, our first statement in any Python code is going to be importing all of the libraries we plan to use in this script. using an import statement. And here, I am importing pandas and using this alias PD so we don't have to keep writing out pandas over and over again when we are accessing all of its functionality. And quickly here, I'm just showing that you can use this __ version to determine which version of pandas is currently installed. If you're having any sort of version issues where potentially some of your code is reliant on a specific version of pandas, this can be a quick check to see which version you have and if that is potentially causing the issue. Okay. So now let's talk about the basic data structures. Here in this image, you can see that we have two of them. The first one is a series. There's just a single, just like one single list of data that has some indices associated with it. So we can see here, this first series could be called height. The second one could be called weight. And data frames are nothing more than collected series. So these are two-dimensional arrays of index data, but now you can see here, index 0 has both a height and a weight associated with it. And something to specify here, Pandas does not require that your series is a hetero or a homogeneous data type, which means that you could have, for example, a 7, and then you could have a string here, and then maybe you can have some other sentinel value here. It doesn't require that these are all the same data type, but it is computationally advantageous if they are. So just really quickly, we'll talk about some of the properties of series. I don't tend to use series directly. I typically am using them only in the context of the entire data frame, but I still wanted to briefly touch on this in case it's helpful to somebody else. So quickly here, we can just create a series and directly give it some data by passing in a Python list. So here, what we're giving it is just 3 data points and then casting it as a series. And we can see that it has automatically associated it with some index values here to the left, and that the series has an associated data type. Now, we didn't have to specify the data type. Pandas is capable of inferring the data type based on what you pass in. And what is it has inferred here, because we are giving it decimal values, is that these are floats, and it's automatically assigning 64 bits. That's something that you can change if you would like to. If we have a given series, we can then extract the values back out of it in an array just by accessing the attribute dot values. And then again, similarly to Python lists, we can access these by index using this square bracket notation. So exactly as we would access a list, we can say data 1, and we will get the second value in this list. Series also have the property that you can assign a different index than the ones that it will automatically give it. So if here it's automatically saying indexes 0 through 2, you can specify, well, I actually want to be able to look these up by index 2, 4, 6, and 8. So what we're providing here is the data that's going to be stored, as well as a custom index for it. So you can see here on the left, now 2 is associated with 0.25, and that's somewhat similar to Python dictionaries. Now we can do lookups inside of this series by index. So this 2 here is just getting back out this 0.25. And the indices do not need to be integers. They can be any type that you would like. So here I'm just using 4 strings, and you can see that the strings are being associated as the indices. And here now, instead of inferring a float type, it's inferred an int64 type because we've passed in all integers. And this is something that Python dictionaries or lists, they don't really have this capability. We can actually slice into this series based on the strings. So we can take this slice of A to C, and it will return 1, 2, and 3. And interestingly, it's inclusive. Normally, these were exclusive. So some slightly strange behavior that might trip you up if you don't know about it. And then similarly to how we can retrieve the values, we can also retrieve the indices of these series using the .index attribute. Here we can see that the data type it's inferred is object, so strings fall under the general category of object.
Let it do that default, it would also still be inclusive if you did 1, 2, 3 there?
That's a great question. So we just got the question, if you let it do the normal indices, would it still be inclusive or exclusive? And I don't know the answer to that, so I'm just going to try it and see what happens. I'll just give this one more value on this. And then we'll see. Didn't actually run this notebook, so let me do that. No, that actually operates the same way that yeah, normal indexing does. Interesting. Okay. As you can imagine, it's not very interesting to just play with this tiny amounts of fake data that we're creating for this example. So let's start by reading some actual data. And this is going to be the penguin data set that I was talking about. So pandas can read a really wide variety of formats. In this case, what we're going to be doing is reading a CSV. So this would be a file that is output by a program like Excel or Google Sheets. And what CSV stands for is a comma separated value. So I would like to take a look at first, just a quick look at the IO page for Pandas. So you can see kind of the large amount of input it can take, and also output. It can output to all of these as well. So CSVs, JSON, HTML, LaTeX, which is really nice if you're trying to create figures for papers, things like that. Quite a few. I'll let you pick through these on your own time, but these do all have their own readers and writers. And then if you were to click on, say, the specific function, it will tell you, here's what you need to provide me for me to actually be able to read the CSV file in. So if we were to read this for, say, our read CSV, we can say that, oh, it's going to take a file path, and that can either be to some local file, a path to a file, or it's going to be able to read a URL. And in this case, we are going to be providing it with a URL. So here's our URL, and I will go ahead and also follow this link just to let you see what a CSV kind of looks like under the hood. I don't know if you've seen this before. Okay, so here's our raw data. This comma separated variable, this very first line here. These are the column names. So the first column, species, second column, island, et cetera, and these are separated by commas. Then everything after this is data. So all of the data that's going to go into these columns is also separated by a comma as well. So let's just go ahead and read that in. And now quickly, we're just going to start looking through it. So two methods to very quickly see what's inside of your data frame. Head is going to show the first 5 rows of the data frame by default, and tail will also show the last 5 rows, excuse me. You can override this behavior if you wanted to, for example, just see the first 3 rows. You would pass that in to the function instead. So running this, we can see that this first print statement outputs the first 5 rows, and you can see that because the rows did not have like index titles, it has gone and automatically labeled them 0 through 4. And then at the very end, we can see that these indices proceed all the way up to 343, and we've only seen 3 at the very end. The info method is going to provide some summary information about the data frame. So let's dig into this a little bit. We can see that there are 344 entries, that they are labeled 0 to 343, and there are 7 total columns. Really, the interesting things here are the non-null count. So you'll notice that there are a couple of the columns, for example, the sex column, that say, okay, there are 334 non-null entries out of 344. So that means there are, at some point, 10 elements here that just don't have an entry where it was expecting to see some value. And then here, the data type, it's showing you also whether or not it's an object, generally a string, or in this case, there are float 64s. Now looking at some of the basic data frame properties, we can check how many rows and columns it has programmatically rather than using info by using the .shape property. Okay, sorry about that. So starting this answer over, there are 2 main ones that, can you hear me now? Okay. So starting over, there are 2 main values that pandas use to signal that there are null values. One of them is not a number, and that is basically in the floating point representation of numbers. That is a sentinel value to say that this number is not a number. If you try to multiply anything against this, it will also result in not a number. So that is one thing that pandas will put into, if it has a numeric column and it's just missing values from the numeric column, that's what it will fill with. Another one that it can use is Python's none object. And it will do that if it's expecting an object. There are other ones, but the use cases of them become smaller, and I would say that those 2 are the most common that you'll run into when you're dealing with null values. Okay. So the basic data frame properties, if you want to be able to check these programmatically for whatever reason, and you're not going to be looking at the result of, say, the info method, you can use the .shape property, which just returns a tuple, the first element of which is the number of rows, and the second element of which is the number of columns. We can also extract a list of the column names, like just using the columns attribute as well. So you can see here that it's just giving us the title of every list. And then if we wanted to, you could also index into that using the square bracket notation. Okay. So now that we have looked at some of the really basic stuff around data frames, let's start actually extracting some data out of it. So you can extract just one column of the data frame using its name. So here we say data frame, and then we are explicitly requesting the column species. And you can see that what this returns is a data frame that only has this one column that we requested. And here's the shape it's printing out helpfully for us. You can also select a subset with multiple columns. So here you'll be passing it in a list that has all of the column names that you want in this new data frame that you're creating. And here we're just selecting species, flipper length, and body mass. And if you would like, you can do an index, integer-based indexing for selection by position. So you would do this using the .iloc, and then you would provide the index that you would like to receive. So this is going to go and select row 0 and provide you all of the columns and information for that one specific penguin. Here you can see that this row, it's inferring that the D type is an object, and that's because when you have mixed objects and floats, it's going to choose object as the more general representation. And as would be expected, this operation also supports slicing. So you can choose 5 through 10, but similarly to normal, this is an exclusive. So you'll receive as the last index, index 9. So I'll give you guys 2 quick minutes just to try selecting rows 5 through 9 and columns 1 and 2. Yes, so it will create a subset data frame that you can store in a new variable and then work with for analysis. And to my understanding, Pandas was specifically built to bring the concept of data frames into Python. So it will be very similar to, it should be very similar if you're coming from an R environment. Okay. Hopefully everybody's had the time to work through this exercise. I'll go ahead and show the solution. If I can get it to drop down. Okay. So similarly to what you would expect from other Python notation, you can provide a slice into this 2-dimensional object by providing the first indices and then the second indices separated by a comma. And then again, because it is exclusive, we just provide a number that is 1 past the last index we actually want to grab.
All starts with 1 instead of 0.
That was just because I asked for columns 1 and 2. We could certainly have it start from 0 to 2. But yeah, the indexing in these is starting from 0. Okay, so we can also select by condition. And generally this will take the form of data frame, and then inside the bracket, we will put the condition that we are looking for. What this is going to generate is a series of Boolean values being true or false values. And wherever this condition evaluates to true, then it will return that index. And wherever it evaluates to false, it will cut that index out and not return it to you. And that's also called a mask. You'll see it very commonly referred to as a mask or a Boolean mask in the Pandas docs, and generally when you're reading about it online. So one example condition would be, okay, let's just find all of the female penguins. So we would say, all right, any column or any row where the sex column equals female, we want to get that one. So the condition by itself is returning the Boolean series. So we have our trues and our falses. And then if we feed that condition into the data frame, then we can see that it's only picking out the values for which it is true. So row 0 evaluates to false and is not returned as part of this filtered data frame, whereas 1 and 2, because they are both female penguins, do make it. And so on and so forth. So you can see that in total, there are 165 that meet the condition. And whereas this is just doing a string comparison to see if this string here matches the string that we've passed in, you can obviously do many type of conditions that are supported by Python. So for example, we're doing a numeric condition here where we're just checking to see if a number is greater than 200. And it works very similarly. We can also combine multiple conditions together. So here we're just looking for penguins that have a certain flipper length and are from a specified island. We are combining these conditions using the AND operator. And you'll notice that this AND operator doesn't use the word and like you would in Python. It actually has to use this ampersand, which is another slight quirk of Pandas. And like operations like OR work similarly. So OR would use this bracket here. And if you need to look up a list of which are acceptable, that's also in the Pandas documentation as well. And then on top of that, we can do all of these different ways that we've talked about of selecting data and just sort of squish them into one. So in this example, this is a very long piece of code. You'd probably want to break this up across multiple lines, but you can do column selection and then multiple conditions on that column to find penguins with very specific attributes. So I'm going to give you guys just 2 more minutes and ask for the number of penguins that have a flipper length above 200 millimeters. Okay, I think that's about 2 minutes. So the solution that I had for this one was to use the shape tuple. So I extracted just the number of rows where this condition was met. Okay, so we've looked a little bit at selecting specific elements, columns, rows, things like that out of data frames. We can also manipulate them by adding new data and deriving that new data from existing data. So for example, one thing you might want to do is just provide a unit conversion. So that's taking data in one column and then saving the results in a new column. So this first line here is creating a new column called culmen length in inches. If you're curious what a culmen is, I believe that is the terminology for beak. So we're just recalculating the length of their beaks. So to do that, it's as simple as just multiplying this unit conversion factor by the current column name. And then here, all I'm doing is rounding it off to some reasonable 1 decimal point value, and then showing the data frame again. So you can see here that it has appended at the very end here, this new culmen length in inches. And as we were talking about a little bit before, because this third row has not a number value as the length here, that propagates to a not a number as the culmen length here. I also have a side note. So I think when you don't have a ton of experience using Python, or when you are just getting into the practice of using pandas, it can be kind of easy to think about like, well, in Python, when I'm dealing with a list, I would just be trying to do all of these things using for loops to iterate through items and provide and do this, this type of operation. But Pandas is specifically built to speed up these type of operations. And if you were to use a for loop instead of the operation, quote unquote, vectorized operation that we used there, which is just this implicit, okay, multiply 0.3 by this entire column, it's actually going to take a significantly longer amount of time. So I just have this little basic code here that's measuring how long it takes this operation if I'm doing it using this vectorized notation, which is creating the new column based on this old column in this manner. And also if I'm doing it in this for loop where it has to individually go fetch every row, multiply it, and then write it back in. And you can see that it's taking, in that case, it took 40 times as long, 50 times as long, 60 times as long. So you really want to be using the vectorized operations here over doing for loops because the for loops are very slow in this case. And if you're curious about reading into this at all, I have this link here. So if we were to follow it, it's just a Medium post that I found where somebody had done an operation like this, and they have a very nice graph that shows you exactly how much longer this for loop is going to take versus the apply and the vectorized, which are both like the pandas equivalent of a Pythonic way to do something. It's much, much faster to use these than the for loop. And that's going to be relevant as you start working with larger and larger data sets. You want to be processing the data as quickly as you can. It's also very natural to derive new data from multiple columns of the old data. So what I came up with here was just, what if we wanted to know for some reason the ratio of how long their beak is versus how tall the beak is, the depth of the beak. And that is, it looks pretty similar. You would just take one of the columns and then divide it by the other column. Now I'm rounding it off again. But yes, very, very simple, very straightforward. And then similarly, because it's taking two not-a numbers and trying to divide them, again, the math unit in your computer is just saying that that doesn't make any sense. It's still not a number if I try and divide something by something that's not a number. We can also just try to drop values. So let's say we have some value in our data frame that we just don't care about. We don't need it in any further analyses, and we want to free up some of the space in our computer. So you can take specific columns and drop them by name. So here we are saying, okay, please drop the columns species and island, and we are saying along axis 1. So in Pandas terms, axis 0 goes this way. So axis 0 goes along the rows, and axis 1 goes along the columns. So this is just telling it you need to go look for species and islands in the columns instead of in the rows. Make sure I actually run this one. And what you'll notice here is that, okay, we dropped it, and then I actually had it show the head again, and it does not show these two things as being dropped. So what's happening in this case? We asked it to drop and it didn't. What's happening here is that when you run this drop method, what it's going to do is it's going to take the data frame it currently has, create a new one, drop it from the new one, and then return it. So in this case, our variable df has the old data frame in it, and we didn't save the new one. So we need to do one of two things. The first one is we can just overwrite our variable df with the new data frame. So in this case, we're saying, okay, we don't need the reference to the old one anymore. df can now point at this new one that has the dropped columns. And if we do that, df equals df drop, then you can see that the species and island column are no longer in our data frame. Another thing you can do is just use the in-place argument. So what that is going to do is say, okay, rather than returning a new data frame to you that has the requested operation, I'm just going to do that requested operation on the specific one you call me on, quote unquote, in place. So to do that, all you need to do is pass in this additional value, in place equals true. By default, this is false. So here we're just dropping one other column flipper length, and you can see this in place now df is missing the flipper length column. One more gotcha that's worth discussing. If you were to, for whatever reason, have two variables that have the same data frame in them, so we have our df, and now we have this new reference, new df, that is just pointing to the same data frame. And we were to drop Coleman length from df in place. That affects both of them because they're just the same data frame. So you can see that this Coleman length, which was in this previous one, is now dropped from both of them. So you just want to be aware when you're deciding to do either new references or you're using the in place and you're rewriting your old reference. Just keep that in mind if you're seeing like weird problems. You may not be handling the variables correctly. It's also possible to just create a copy before you start doing anything to it. So if I were to do, for example, okay, I want this new data frame and I want it to have everything that the current data frame has, then you can use the dot copy. And then those are completely unrelated to each other. So in this first one, we can drop something in place, and it will only be dropped in df and not in new df because they are now not related to one another. Okay. So similarly to dropping columns, we can also drop rows using the index argument. So everything I just said about dropping columns and how that's going to relate to multiple data frames, multiple references to data frames applies here. So to drop rows, we provide it indexes. And here we're actually we have to go in and go to data frame, access the attributes index. And here what we're doing is saying, okay, give us back the name of all of the indices from 100 to the end. And those are the ones I want you to drop. And then here you can see we're using access equals 0 instead of 1 because that's how we tell it to drop along rows. So looking at the result of that, we can see that now we have only 0 through 99, 100, and past has been completely cut off. So we can also combine this with conditions. So you can drop rows of DF that have some condition like that exceeds a threshold. So go ahead and try dropping all of the rows of the data frame where the penguin body mass is greater than 4,000 grams. I'll give you another 2 minutes for that. Okay, so that's also about 2 minutes. I'll go ahead and show you my solution for that. So this one, a little bit more complicated than what we've seen with just the normal conditions, but the idea is very similar. So the first thing to do, we're getting this data frame that only has the body masses that are above 4,000, asking for those indices specifically, and then dropping those indices. So I just did a quick info here so we can kind of see if that worked, and we can see that looks like there's 172 where this condition is met.
That's why the axis there, just default to 0.
I believe that, yeah, the axis is 0 by default, and then you have to override it with other ones. Yeah. Okay, so and now we're coming back around to the issue that we noticed at the start, and we've kind of been talking about this entire time, which is that we have some null objects in our data. So all I'm doing here is just restarting with a fresh copy in case there's been some other drops that you guys are doing. So we're just reading in that data frame again. And then taking a look just to refresh ourselves, there's 10 that are missing from sex, and then we can see that there are a couple missing, 2 missing rows for some of the numeric values. So the first thing you can do is just find all of the location of the null values using the method isNull. So all I'm doing here is saying, okay, I want to see all of the data where at least one of the values is null. So this isNull is creating a Boolean mask that we can then feed back into the data frame. So we can see here that as expected, we have these 2 rows that are missing the numeric values. And then it's 10, where it's just missing any value for the penguin sex. So we discussed this a little bit, not a number, that special floating point value. That's in the IEEE specification for floating point that says this isn't a number, so whatever arithmetic operation you're feeding me into, put not a number back out. Don't return garbage, return this sentinel value that indicates that this is not a correct value. So just to show this really quickly, I have this Python where it says, okay, return not a number as a float, multiply it by 1, and that result is also not a number. And then as we saw earlier, it's also extended to data frames. So this again is just, okay, we're creating this ratio, but any values where it took in at least 1, in this case, both not a numbers, it's just returning also not a number to that new column. So the simplest way that you could deal with this is just to drop all of the rows that don't have some value using the drop NA method. So in this case, we're saying, okay, drop any null, like any rows with null values, and we'll go ahead and do it in place. So we can see that now it has dropped, because there are only 334 rows remaining, it's dropped 10 rows, and we know that everything in our data frame has some value associated with it. Here I give just a quick overview of some of the other methods for detecting and dealing with null and non-null data. So isNull and not null are obviously opposites of one another that are just going to return a mask that either selects everything with null values or everything without null values. We saw drop NA, and you can also do fill NA. So what that would do is instead of dropping the rows, it's going to put the value that you specify anywhere that it detects a null value. And you'll want to check the Pandas documentation for the specific function arguments. But for example, one thing you could do is just say, okay, anywhere you find a null value, as a number, just put a 0 there instead. Things of that nature. Pandas also makes it really easy to quickly calculate summary statistics for your entire data set. So now that we've gotten rid of all of the null values, one thing we can do is use the .describe method. And what this is going to do, we can see here, is return some of the descriptive statistics. So it's going to count however many like not null values it has. It's going to give you mean and standard deviation for that value, the minimum value, the maximum value, and also these are the 3 quartiles of that value for every single one of the numeric values. So you'll notice that it has the numeric values and it's not showing the categorical variables. If we did want to get some of the statistics on these categorical variables, so anything that's not a number, has some sort of label associated with it, things like that, what we can do instead are specify the data frame's categorical variables only. So in this case, species, island, and sex, and call .describe on that. So what that will return instead is, again, a count. It's going to tell you how many unique values it's finding. So in this case, for species, there are 3 unique values for species, 3 unique values for the island, and I actually don't know why it's saying that. Oh, there's a dot on one of them.
Male, female.
Oh, it has a dot. Okay. Interesting. It's also going to show what the top value is in that frequency. There's a question, is there a way to list all categorical variables? And off the top of my head, I'm not 100% sure how you could do that. I think that you could probably do some sort of filter on the columns for like object columns. I would have to look at the Pandas documentation, but I'm sure that there's a way that you can have it tell you, give a list of the categorical variables. If we might have some time here at the end, so I can go looking at the Pandas docs for you as well. Let me write that down. And then, so this, because this is giving you back a data frame, you can actually just access this using all of the same methods that we've already been using. So I saved this first one in a variable called stats. So we have these columns, and then the rows, rather than having an integer index, have a label associated with them. So now we can look at, okay, stats, grab one of the specific columns, and then we could also grab it by the label. Okay, naturally you can also sort and group data. So here, what I'm doing is just sorting values by island. By default, it's ascending, and in this case, that's normal alphabetical order for strings. So you can see it's got all of the Bisco Island penguins first, and then Torgerson after that. You can, of course, do a numerical sort, and to do a descending sort instead, you would set the ascending to false. So here we can just see that sorting by flipper length, descending, we can see that it is indeed going down. You can also do a convenient operation called group by, and what this is going to do, this is, let me double check that this is, okay, yes, this is what I wanted to do. Okay, so this group by operation is very helpful because what it will do is break your data frame into some smaller data frames based on the whatever condition you give it. So in this case, we're saying, okay, please group all of the penguins by island. So it's creating some smaller data frames, and then I'm asking it for now take the mean of all of the numerical columns. So we can see that for all the Bisco penguins, these are the means across all of the numerical values, and so on for all of these other penguins across the specific islands. And then this is just trying to show how we can be putting together all of these basic operations to start doing more and more interesting operations on our table. So here what we're just doing is getting two different lists of the male and female penguins. We're sorting them by the body mass in these first two lines. And then we're taking only the top 5. And then what we're doing with those two is concatenating those two tables together to make a new table that has these top 10 heaviest penguins, and then showing it here. So the concatenation, what that's doing is just taking males and then it's appending the females right after them. So we can see that, yes, the 5 male penguins are first and then the female penguins are second. Okay, that was, I think, why I was doing that.
And then top head, is it contains first 5 of each grouping?
Yeah.
Next question, 0 to 5, 20 to 4. So.
Yes, okay, so what it's doing there, the reason it's doing that is head is the function that it's calling on it. So it's basically taking these 3, grouping it into these 3 data frames, performing that function head, and then giving you that result. Whereas it's performing mean when we do, for example, this block down here. Very good catch. Yeah, so any operation that you can call in a normal data frame, you can call on these group bys as well. So maybe, okay, I have 2 more exercises for you. The first one would be sorting all of the female penguins by flipper length. And then the second one is you can group all of the female penguins by island and then just get some descriptive statistics for only the female penguins. So give you maybe a couple of minutes to do that because I want to talk about actually outputting data. Okay. I'll go ahead and reveal my solutions, although I'm sure that you can also do that if you would like. Not too much to talk about here that we haven't already been talking about besides, again, we're just taking all of these small building blocks that we have and using that to create more interesting functions. So here, because describe is a function that you can call on a data frame, you can also just call it on these, what the group by returns. One nice thing that Pandas can do for you is take a data frame and format it in some various ways. So the 2 that I have used the most are Markdown and LaTeX. So to do this, you would just take your data frame and call to Markdown. And you can choose whether or not you want to show the indices. In this case, because they're just numbers that don't relate to the actual penguin itself, I've chosen false. You can see here, it just will dump that directly to standard output. And then you can see that this is actually that same table, just being rendered as a markdown table. And you can do this as a LaTeX table as well, although Google Colab does not have a built-in viewer for that. So. And then finally, once you're done doing all of these different operations, you've picked the penguins that you want to explore, you've done whatever describes, group bys, etc. that you've done. And now you have a data frame of your final data that you need to save somewhere. So you can export this back out into other data formats like we talked about in this IO section. I just showed here an example of writing it to an Excel format, the .xlsx. So what it's going to need here, and it mentions this in the page for specifically the to Excel function as well, is you need these 2 libraries that support writing to Excel. But after importing them, no, I didn't actually run this. So let me do that real quick. It quickly just writes it. And then if we come over here into our Google Colab, we can see that it's saved this here. I just did a very quick like formatting where we say output and then, it fills in today's date in here. So you can see that it's filled that in for you. And then one thing, if you are running in a Google Colab environment instead of on your local computer, Google Colab will delete this after you close the session and then we're to reopen it. So just don't forget to save it before you close everything up. So that's what I have for my material. I wanted to also share, we have another Introduction to Pandas notebook that was previously developed for a workshop series that it goes through another tips data set, and you can see how you would possibly use this with printing making graphs as well. So you can either do that specifically with pandas, or it will also give you some examples of how you would do that with matplotlib and Seaborn. So I think this one is helpful to look at. And the third data set that is explored in it is also a time series data set, which we did not talk about, and I think is a very common way that you'll see data. So it would be worthwhile to look at this one if you are going to be using data that has specific times associated with it, and it will help you get started there. So any last minute questions before we sign off? Okay, thank you everyone for attending. We've hit the end of our time. I hope this was helpful.